So let's see. We said it could be a triangle. We said it could be a quadrilateral. Is this a quadrilateral? No. What's the definition of a quadrilateral? Anything with 4 sides? Okay. Is this a polygon? Why not? That would be a pentagon, which is a polygon. We're trying to think about what makes a polygon a polygon. Is this a polygon? Why? Because what? The lines aren't connecting. I heard someone else say something. It doesn't close. So a polygon is a closed figure made with line segments. It's a closed figure made out of line segments. Is this a polygon? No, it's not a polygon because I didn't use line segments to create that. Okay. But any other 1, 2, 3, 4, 5, 6, 7, 8, 9, that's a polygon, right? Anytime you just join a bunch of line segments that don't overlap, kind of like this, right? That's a polygon. So today we're going to classify polygons, but the type that we're going to classify today are triangles. So our I can statement is I can use slope relationships to classify right triangles. Whoops, there should be an S on that. Right triangles and use distance to classify isosceles, equilateral, and scalene triangles. Now, when I wrote it on my paper, I fit it all in there, but I just think I wrote too big. So I'm going to leave that up there for a second. So I can use slope relationships to classify right triangles, and I can use distance to classify isosceles, equilateral, and scalene. So if I have a right triangle, what do I know? Has a 90-degree angle. That means what happens to the two lines that create that 90-degree angle? What do they have to be? Legs. Think about their slopes. We're talking about their slope relationship. What do they have to be?
If they connect, they have to be perpendicular.
They have to be perpendicular. So that's how we're using the slope relationship. We're looking for if we've got a right triangle, if we're trying to prove something's a right triangle, we have to prove that the two lines, the two segments that come together to make that right triangle are perpendicular using slopes. How could we use the distance to classify a triangle as isosceles, equilateral, or scalene?
Well, for isosceles triangles, their sides are congruent.
So we have to show that two of them have the same measure. Okay, what about equilateral?
all three of their sides are congruent.
All three are the same, so we have to show that all three sides have the same measure. What about scalene?
All their sides are different lengths.
So we still have to use the distance formula for all three sides, but we have to show that none of them equal each other. Does that make sense? So I think that's what I wrote. I wrote, well, a triangle is just a polygon with three sides. A right triangle contains a right angle, and we use slope to prove that a pair of adjacent sides are perpendicular. Do you guys remember what perpendicular slope looks like? Perpendicular slope is what? Go back to lesson 4.2, perpendicular and parallel lines. That'll tell you what perpendicular slopes look like. Perpendicular slope is what?
They're two lines that intersect to form right angles, and their slopes are opposite reciprocals.
Yeah, that's what I'm looking for. Opposite reciprocal. That's what we're looking for. Opposite reciprocal. Okay. Oh, that should be under the right triangle. Sorry. I'm moving that up to under the right triangle. My bad. I thought that's where that was. All right, an isosceles triangle we said has two congruent sides, and we're just going to have to use the distance formula to show that two sides have the same length. Equilateral, all three sides are congruent, so we're going to have to use the distance formula for all three sides. And then scalene, all three sides are different, and again, using the distance formula. So today when we classify polygons, we're going to do it using coordinates on a coordinate grid. Slope and distance formula. That's it, slope and distance. Okay? What do we think about that? Okay, let's get started. Raise your hand if you still need this up here. Perpendicular slope is opposite reciprocal. Okay. So example 1, the coordinates of the vertices of triangle ABC are A is -5, 3, B is -1, -2, and C is 2, 3. What do you think we're going to do first? Yeah, the first thing that we're going to do is plot those points and connect the points together with a line segment to create a triangle. So let's see. A is -5, +3. And when I plot my points, I label it. So this is A. B is -1, -2. And C is the ordered pair 2, 3. So then I'm going to connect my points. I'm going to connect my points and make a triangle. So we have to show using distance that we have a scalene triangle. So we're going to use distance. Okay, we're going to use the distance formula. So what side do you want to do first? We have to do all three sides. Which one do you want to do first? It makes me no difference. AB. Okay, so let's calculate the distance of segment AB. So this is how I write it. Distance of AB. So let's see. I'm using the ordered pairs here and here. So I have the square root of -5 minus -1, the quantity squared, plus 3 minus -2, the quantity squared. So what happens when I subtract a negative? Turns into a what? Great big plus sign. Great big plus sign. So what is -5 plus 1? -4. So I really have -4 squared plus, and 3 plus 2 is 5 squared. Well, what is negative 4 times negative 4?
Positive 16.
Positive 16. And what is 5 times 5?
25.
And 16 plus 25 equals?
41.
So the distance from segment, or the distance of segment AB is the square root of 41. Do I have to simplify that? Can I just leave it like that? What are you thinking? We could put that into our calculator, but all I have to do is just show that they're not the same, right? So I'm just going to leave it as a radical. I'm just going to leave it just like that. And I'm hoping that AC doesn't have a distance of the square root of 41, and I'm hoping that BC doesn't have a distance of the square root of 41. So which one do you want to calculate next, AC or BC? BC. Okay, so the distance of segment BC. All right. Negative 1 minus 2, the quantity squared. Plus negative 2 minus 3, the quantity squared. Okay, so what is negative 1 minus 2? What does that become? Signs are the same. We add and keep.
Positive 3.
We're adding them. So we keep the sign. We add the numbers together and we keep the sign.
Negative 3.
Good job. So I have negative 3, the quantity squared, plus, what is negative 2 and negative 3? When I add these together. Negative 5, the quantity squared. Good job. Okay, what is negative 3 times negative 3? Positive 9. And negative 5 times negative 5 is? And 9 plus 25 is? 34. So the distance of BC equals the square root of 34. Okay. Those aren't perfect squares. I can't reduce them or anything. So is A and B, the distance from A to B, different than the distance from B to C? Okay, so we're on our way. The last one that we have to do is we have to calculate the distance from A to C. Now, I know that I can just count those grids, but I'm going to use the distance formula to show my work. So let's see, negative 5 minus 2, the quantity squared, plus 3 minus 3, the quantity squared. What is negative 5 minus 2? Negative 7. So I have negative 7, the quantity squared, plus, what's 3 minus 3? 0. What's 0 squared? Okay, so plus 0. So what is negative 7 times negative 7? A negative times a negative is a? Positive. And what is the square root of 49? 7. So the distance from A to C is 7 units. And that makes sense because I can actually count 1, 2, 3, 4, 5, 6, 7. So this has a side measure of 7. AB has a side measure of the square root of 41. And BC has a side measure of the square root of 34. Are any of those equal to the other? No, they are not. So we can say that triangle A, B, C is scalene because, whoops, it'd be nice if I could spell that. Because AB does not equal BC, does not equal AC. All three sides are different. What do we think about that? That's a lot of steps. Got to show a lot of work on this, okay? These are called coordinate proofs. Raise your hand if you need more time with that. Okay. Example number 2, given triangle HIJ with coordinates HI and J, use coordinate geometry to prove that it's an isosceles triangle. So what are we going to show if we're trying to prove that it's isosceles? Yeah, right there. Yeah, give it to me. So what are we going to show? If we're trying to prove that we have an isosceles triangle, what are we going to show? We wrote it on the front. What do we show?
We show that two sides are congruent.
Two sides have the same measure. We have to show that two sides have the same measure. Okay? So I'm going to write that little note because I think that's important. We have to show two sides have the same measure. And what formula are we going to use? Yeah, with distance. That's what we have to show. So let's go ahead and plot our triangle. So H is the ordered pair 5, 2. This is a teeny little triangle. I is the ordered pair 6, 1. And J is the ordered pair 8, 4. So this triangle is this little baby guy right here. So what two sides do you think are probably going to be congruent? I'm going to write that down. Go ahead, Ariana. Yeah. You think, okay, hang on a second. Let me ask that again. What two sides do you think are congruent? And what'd you say? Okay, so those are points. Sides are two letters smashed together. So where is side HI? Isn't that this little, this is point H and this is I. So do you think that that side is congruent with one of the other sides? Okay, so let's name those. So you think that probably, I think that probably HJ is going to be equal to IJ. That's what I think, because that's what it looks like. Does that make sense? We name the sides by the two endpoints that kind of cover it. So this is side IJ, and this is side HJ. HI is the teeny tiny one. We know that that's probably not congruent to anything because it's the smallest side on there. Okay? So we're going to use the distance formula. So we're going to find the distance of HJ and IJ. So let's start with HJ. The distance of H to J. I need to squeeze it up just so I can see my order pairs. Okay, so 5 minus 8, the quantity squared, plus 2 minus 4, the quantity squared. So what does 5 take away 8? Is it? It's negative 3. So I have negative 3, the quantity squared, plus, what does 2 take away 4? Negative 2, the quantity squared. Okay, so what is negative 3 times negative 3? 9. And what is negative 4 times negative 4? Or sorry, negative 2 times negative 2? 4. What is 9 plus 4?
13.
So the distance from H to J is the square root of 13. Can I leave my answer like that, or should I turn it into a decimal? What do you think? Leave it just like that, yeah. Because if side JI is equal to that, it will come out to be the same exact thing, the square root of 13, okay? So don't make it any harder than it already is. So now let's look at finding the distance of IJ. Okay. So I'm going to start with the x-coordinate of point I, which is 6. So I have 6 minus the x-coordinate of j, which is 8, the quantity squared, plus now my y-coordinates, 1 minus 4, the quantity squared. Alrighty, what is 6 minus 8? Negative 2. So I have the quantity of negative 2 squared plus, what is 1 minus 4? Negative 3, the quantity squared. What is negative 2 times negative 2? And what is negative 3 times negative 3? What does 4 plus 9 equal? So the distance of IJ is the square root of 13. Are those equal to each other? Yes, they are. Absolutely. So what can we say? Triangle HIJ is isosceles because HJ equals IJ. And we proved that. We proved that their distances are the same, which is their lengths or their measures. How are we feeling about this? We're just using distance formula so far. That's all we've done is just distance, 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 distance. Okay, we have one more example. One more example. Example 3 says, if the vertices of triangle PQR are PQ and R, show that triangle PQR is a right triangle.
I think I just realized that I actually wrote all the work on the wrong sample.
Oh, that's all right. I'll
Okay.
There's filled out ones over here.
I'll just like put an arrow to indicate that I did the wrong sample.
Okay. And I have filled out notes too. You can have a copy of that as well.
Okay, thanks.
You're welcome. So how are we going to show that we have a right triangle? We talked about this at the very beginning. What does it say on the front of your notes? How do you prove that you have a right triangle, Daniel? We have to show perpendicular slope, right? So we have to show perpendicular slope, which is just the opposite reciprocal. Okay, so I say that we graph it and get an idea of what two lines look like they're perpendicular. Is it an emergency? My passes are right up there. So let's graph it and figure out what two lines look like they're perpendicular in this triangle. So let's see. -6, -5. That's P. 4, -5. That's point Q. And 4, -1 is point R. So what two line segments appear to form the right angle? What do you think, Aiden? What two line segments appear to form the right angle? So the line segment, this whole thing is named by its two endpoints. So what's this line segment called? It's made by what endpoints? So PQ, I'm gonna put it looks like segment PQ is perpendicular to this whole line segment, right? Which is QR or RQ, it doesn't matter how you say it. That's what it looks like. Can you what? Yeah, go right ahead. It's in the Student Center. Okay. So how are we going to do that? What do we have to do? Student Center, all that right over there. There's labeled. So how do we show that they're perpendicular? What are we going to do? What does it say? Show what? Well, yeah, but I mean, how are we going to show that those two line segments are perpendicular to each other?
Whatever that word says.
Opposite reciprocal? Yeah, what is opposite reciprocal? What formula are we using? What are we calculating? The slope. So we have to use the slope formula. So we have to find the slope of PQ. What's the slope formula? No, that is slope-intercept form line equation. Slope formula. M equals, perfect. This is how we use slope, right? So we're using points P and Q. So let's see, -5 minus -5 over 4 minus -6. Okay, -5 minus a negative, that turns into a great big plus sign. What's -5 take away 5? 0. 4 minus a negative becomes a plus. What's 4 plus 6? Okay. What is 0 divided by 10?
0.
Use your calculator. Why don't you have calculators?
Yeah, that's a 0.
Some of you are saying it's 0. Some of you tell me you can't do that. Some of you are saying it's undefined. It's 0. What kind of a line has 0 slope? A horizontal. Good job. Awesome, Victoria. So that means that PQ is a horizontal line. Is that true? Yeah, it is. PQ is a horizontal line. Are you guys looking at the same line I'm looking at? Well, you should be. Okay. So now let's find the slope of QR. Okay. So the y-coordinate of R, -1, minus the y-coordinate of Q, -5, over the x-coordinate of R, 4, minus the x-coordinate of Q, which is 4. So let's see, that minus and negative turns into a great big plus sign. -1 plus 5 is a positive 4. And what is 4 minus 4? What is 4 divided by 4? Sorry. What is 4 divided by 0? That is undefined. Why?
Because the 4 is on top.
because you cannot divide by 0. You can't take something and break it into nothing. When you divide by a number, you're breaking it into that many pieces, right? How can you take something and break it into nothing? That's why it's undefined. It's not possible, okay? What kind of a line has undefined slope? A vertical line. Okay. So, are vertical and horizontal lines perpendicular to each other? Yes, they are. Vertical and horizontal lines are perpendicular to each other. So, triangle PQR is a right triangle because PQ is perpendicular to QR. And then I'm going to put a special note down here that says horizontal and vertical lines are perpendicular to each other. That is super duper important.